Betelgeuse is one of the brightest and most famous stars in the night sky. Found in the constellation Orion, this red supergiant star has captured the attention of astronomers and stargazers for centuries. Its striking reddish color and enormous size make it a standout among stars visible to the naked eye. To truly understand Betelgeuse, we need to grasp how massive and large it is. Betelgeuse's radius is about 764 times that of our Sun. To visualize this, imagine replacing our Sun with Betelgeuse at the center of the solar system. The star would stretch beyond the orbit of Jupiter, swallowing Mercury, Venus, Earth, Mars, and the asteroid belt. This immense size places Betelgeuse among the largest stars visible to us. Located approximately 548 light-years from Earth, Betelgeuse is relatively close on cosmic scales, which explains its brightness despite the vast distance. It's classified as a red supergiant because it is a very old, massive star nearing the end of its life cycle. Stars like Betelgeuse are in a late evolutionary stage where they have expanded enormously and cooled on the surface, giving them their reddish hue. One key characteristic of Betelgeuse is that it's a variable star. This means its brightness naturally changes over time due to complex processes in its interior and outer layers. These brightness fluctuations usually follow a somewhat regular pattern caused by pulsations in the star's outer shell. These pulsations make the star expand and contract slightly, changing how much light it emits. But in late 2019, something remarkable happened. Betelgeuse began to dim dramatically, far beyond its usual variation. Its brightness dropped by almost 40%, a huge decrease that shocked astronomers and space enthusiasts alike. This event, widely referred to as the Great Dimming, sparked intense speculation. Many wondered if this sudden change was a sign that Betelgeuse was about to explode in a supernova, a powerful stellar explosion marking the death of massive stars. A supernova from Betelgeuse would be a spectacular event, visible even during the day here on Earth, and one that would produce massive amounts of energy, light, and cosmic material. It would be a once-in-a-lifetime cosmic display, occurring somewhere within the next 100,000 years or so, according to scientific estimates. However, as researchers collected more data, the explanation for the dimming shifted away from an imminent supernova. High-resolution observations revealed that Betelgeuse had ejected a large cloud of dust that partially blocked the light from its surface. This dust cloud acted like a veil, causing the star to appear much dimmer than usual. Essentially, it was not that Betelgeuse had become fainter internally. Rather, the dust was obscuring the light reaching Earth. Following this event, in 2023, Betelgeuse surprised astronomers again by suddenly brightening to about 2.5 times its normal brightness. This rapid increase in luminosity was yet another sign of the star's dynamic and unstable nature. The changes in brightness are linked to the star's turbulent atmosphere, massive convective cells, and irregular mass loss. To better understand these processes, astronomers have turned to the James Webb Space Telescope, which launched in December 2021. Webb is the most powerful space observatory ever built and observes primarily in infrared wavelengths. Infrared light can penetrate through dust clouds that obscure visible light, allowing scientists to see the cooler gas and dust surrounding stars like Betelgeuse. Webb's observations have confirmed that Betelgeuse is actively shedding material. Vast amounts of gas and dust flow outward in bursts. This mass loss is irregular and causes the star's atmosphere to change shape and brightness in complex ways. These findings highlight just how unstable and dynamic a red supergiant's life can be in its final phases. Some astronomers have speculated about the possible existence of a companion star near Betelgeuse, sometimes informally called Beetle Buddy. The presence of a companion star could explain some irregularities in Betelgeuse's shape and behavior through gravitational interactions. However, no companion star has yet been conclusively detected, so this idea remains speculative. One of the biggest questions surrounding Betelgeuse is, when will it explode? Current models suggest that while Betelgeuse is indeed in its final life stage, the supernova explosion is not expected anytime soon. Estimates place this event at anywhere from tens of thousands to hundreds of thousands of years from now. When Betelgeuse finally goes supernova, it will briefly outshine every other star in the night sky and could be visible even during daylight for weeks. Importantly, Betelgeuse's distance from Earth means that this explosion would pose no threat to our planet. The energy released would be enormous, but far enough away to be safe. Scientists continue to observe Betelgeuse closely using a combination of ground-based telescopes and space observatories, including Webb. These ongoing studies provide invaluable insights into the life cycle of massive stars, helping us understand stellar physics and the processes leading to supernova explosions. Betelgeuse serves as a nearby natural laboratory, allowing astronomers to witness firsthand the turbulent final chapters of a star's life. The data gathered from this star enriches our understanding of how the universe evolves and the ways massive stars shape their cosmic environments by spreading heavy elements necessary for the formation of planets and life. Thanks to the cutting-edge technology of telescopes like James Webb, each new observation brings fresh knowledge about Betelgeuse's behavior, shedding light on the complexities of stellar evolution.